With adding and subtracting under our belt, we're ready for multiplying and dividing. This one comes with just a small little twist, some new information. So I brought this guy back. We know that the square root of -1 equals I. Okay, we're going to use this a little bit for this first example. If I have 2i times 8i, 2i multiplied to 8i. So I'm going to take 2 times 8, which is 16, and I times I, which is I squared. Again, this behaves just like our x's. Any variable, multiply the coefficients, multiply the variables. But this is where my twist comes in, that I squared. If we look at this example here, if I square both sides, so now I have I squared. What happens if you square a square root? If you remember, those are inverse operations. They're going to cancel each other out. And I'm now left with the fact I squared equals -1. Okay, I squared equals -1. We're now going to use that anytime we end up with this I squared. So I'm going to substitute I squared equals -1. So I'm substituting in that -1, and I get -16. So when I multiply these numbers together, two imaginary numbers resulted in a real number. Okay, next example, 3i times 4 minus 5i. So we still have to remember our distribution. So I'm going to take 3i times 4, which is 12i, and 3i times -5i, which is -15i squared. Again, we're going to make that substitution. I know that my I squared equals -1. So this is -15 times -1, which is a positive 15. When we're using complex numbers, we want to list the real number first. So I'm going to rewrite this as 15 plus 12i. Simple enough, right? Okay, one more multiplication practice problem. We're going to do a double distribution. 2 plus I times 3 minus 7i. So we have two binomials, a complex number times a complex number. All we're going to do is distribute and simplify. So we have 2 times 3, which is 6. 2 times -7i, which is -14i. I times 3, which is a positive 3i. And I times -7i, which is a -7i squared. So here I have some like terms. So 6 minus 11i. Then I'm going to substitute in my -1. So I have 6 minus 11i plus 7. So that's going to result in 13 minus 11i. Okay, multiplication. The main thing we want to remember, I squared equals -1. Make the substitution and simplify. So now let's take a look at division. Whoops, we're going to leave that up there because we're going to use it. Dividing with our imaginary numbers is similar to our radical division. Mostly we just don't want I in the denominator. So let's take a look at a couple of examples. Say we have 7 over 3i. We don't want our denominator to be an imaginary number. So to get rid of I know if I is squared, it's going to become -1. So I'm going to multiply by I. I can't square it. I have to multiply by I. So this is going to give me 7i over 21i squared. I squared is -1. So this ends up giving me 7i over -21. So we could write that as -7i over 21. Simple enough. All we're doing is multiplying by that I to get I out of the denominator. So let's look at 3 plus 4i over 6i. Now our numerator is a binomial, but that doesn't change anything. I'm still going to come in and multiply by I to the numerator and to the denominator. In the numerator, we're going to distribute, so that's 3i plus 4i squared all over 6i squared. So I'm going to make my substitutions for my I squareds. That's 4 times negative 1 and 6 times negative 1. So we're looking at 3i minus 4 over negative 6. This is also equal to 4 minus 3i over 6. I switched the order for my complex, real number first, and then I changed the signs because the negative 6 and the negative 4 are going to reduce, and it's going to make my negative 3i. If you've got questions about that, ask. If you leave it here, I'm not going to mark it wrong because it is correct. It's just not good math grammar, but you can do it. All right, one last example. It's going to be a little bit of a longer one. Bear with me, you guys got this. So if we have 10 over 8 minus 5i. So what's happening here, instead of the binomial in the numerator, I have a binomial in the denominator. So what's going to happen is I have to multiply by the conjugate. So if you remember, with the conjugate with the radicals, here I have a minus bi. Its conjugate is going to be a plus bi, or vice versa. So if you have a plus, its conjugate is going to be negative. So I'm going to multiply by my conjugate to both the numerator and the denominator. So let's take a look to see what happens. Distribute in the numerator, I'm going to get 80 plus 50i. In the denominator, 8 times 8 is 64. 8 times 5i is 40i. Negative 5i times 8 is negative 40i. And negative 5i times 5i is negative 25i squared. The numerator is pretty good, but here in the denominator, I've got like terms in the middle. 40i minus 40i, well, that's 0. And then I'm going to make my substitution for my I squared. That's going to be 64 minus 25 times negative 1. So 80 minus 50i over 64 plus 25. So if I combine like terms in the denominator, 64 plus 25 is 89. So that is rationalizing or simplifying the denominator, just making sure that imaginary number is not in the denominator. Tongue-tied there. Okay? If you've got questions, let me know. Good luck.